Hi everyone, so welcome to this video. So today in this particular video I'll be talking about one of my portfolio projects, that is an exploratory data analysis project on fake job postings. The data set is collected from Kaggle, and the data set I think was posted 2 years back. So I have tried to get my hands dirty on this project, and hopefully you guys will like it. So let's jump right into it. So in today's day, fake documents and all these things are really not something new to us, right? So there is a sarcastic thing called, which is also a real thing. It's called WhatsApp University, where we get bombarded with fake documents and fake news. So this is a real problem that actually we can tackle with the help of machine learning. So, and to build the model, obviously the first work that we need to do is the exploratory data analysis. So let's jump right into it and see what we can find for this particular job scam alert project. So this particular data set, it has 18,000 job descriptions, and out of which 800 are fake. So let's say that we are it is evident that we can see that the data set is highly imbalanced, and we are going to create a classification model out of it. Although I am not addressing the classification model in this video, I'll keep it for another video. So let's start with it. So first, let's install the necessary packages that we have. So first of all, obviously pandas is needed, numpy is needed, and for the visualization purpose we need matplotlib and code. And we are need some other NLP related packages that we have already installed here, and we will address it as we go along. So let's first dive right into it. Let's first download the data. So this is a gdown file that I have taken from my Google Drive. So this is kind of easier for us to get it from there. Then we have started with reading the CSV file. So as we can see, there is a lot of text data, and there are a lot of punctuations and all. And we can see there are categorical data as well, like telecommuting has company logo, has questions, and the text field also there, right? Like let's say company profile, description, requirements, these things. So if we go to the shape, we can see that it has 17,880 rows and 18 features. So the columns are, as we saw earlier, so this is the column, and as we can see, there is a target column here which is fraudulent. So let's see what are the data types we have. So as we see df.info, we can see that we have two types of the data types here. One is the object one, and the other is integer type. And we can also see that in a lot of them, not all of them are non-nulls. So it is very evident that we have some null values. So let's define a function that can actually show us, and that can actually make a data frame out of the null values, and we can see the total count and percentages. So here I have actually made a function, I created a function which actually shows the null values. So if we go along and see, so salary range has the highest null values, which is 83.96. So this is very hard to actually address these things, address null values, but we'll go along and see how we do it. So if we describe the things, we know we have 4 categorical data, and that is what we are seeing. But we know, except for job ID, telecommuting has company logo and has questions. These are basically binary, either 0 or 1. So we can see that the values will not be much of help here. So let's see, and we have already seen the info and the data types as well. So let's jump right into the univariate analysis. So let's start with how many uh, how our target variable is fraudulent. So let's see what is the percentage. So as we can see, the non-fraudulent is almost 95% and the fraudulent is merely 4%. So this is a very highly imbalanced data. So that's a problem and we need to handle it, and we'll see how we can do it. And next let's see how many duplicated rows we have, and we can see there is no duplicated rows that we have. Then comes location, and there is a very important feature to see that in location we have comma separated values. GB means Great Britain maybe, LND means London's code, and it is London. So London have the most job postings. We have not yet seen is it fraud or is it non-fraud, but what we can see right here is that London has the most postings and New York comes second, San Francisco comes third. Then comes salary range, and this is categorical, and there are 874 unique salary ranges that we can see, and that is really tough thing to address because salary range has 83% null values, and out of those 17% non-null values that we have, we can see there are 874 unique salary ranges. So probably we can drop salary range because this is going to create a problem. But before that, we will definitely see how salary range is changing with null fraudulent and fraudulent data. So next comes department. We can see sales have the highest departments, engineering, marketing, and all. Then comes title. English teacher abroad occupies the first place. Then comes customer service associate. So then comes company logo, and we have normalized here also. We can see almost 80% of the companies have logo and 20% doesn't. For telecommuting also, it is pretty imbalanced, that we can see that 95% of the companies have telecommuting but 4% doesn't. Employment type, we can see there are many employment type, but we also know that in these files probably that we have let's see again. I think we have some, yeah. So as we can see, we have null values here also, so we need to handle it and then see how the distribution is. But let's go along with it. So employment type, as we can see, the highest is full time, then comes contract, then part time, and then temporary, and then other. And for employment type, if we see the distribution, we can see there is a distribution like this, but we can't definitely say that this is Gaussian because the full time is highest and that is where the peak is, but we can't say it is some kind of distribution that we know so far. So then comes industry, and we can see that IT comes first, computer software comes second, internet comes third, marketing and advertising comes fourth. And for required experience, we can see that the job demand for mid-senior level is the highest. Then comes required experience and the visualization of it, and we can see that here also the distribution we are seeing is not giving us any inference, but it's good to see that how they are distributed. Then comes the required education, where bachelor's degree is in most demand, and second comes highest high school or equivalent. Then for that also we have plotted the univariate analysis, and we can see that it's not helping much, but we are visualizing it anyways. For function also, information technology comes first, sales comes second, engineering comes third, and that like that. So required education, if you see, well, bachelor's and these are equivalent. So then let's explore salary range and see, because salary range has the highest amount of null values. So let's split this salary range when the fraudulent, it is non-fraudulent and it is fraudulent. So we have taken two variables, and first we have actually tackled the null values, and we are replacing the null values with a word called unknown. And as we can see, it has 83% null data, so it is replaced with, most of the cases we can see unknown. And the salary range, we have taken two variables, real salary range and fake salary range, and we're trying to see if we can find any inferences from there. So whatever I have found here is that when it is it is non-fraudulent, that is fraudulent is equal to 0, then the unique number of salary range is 829, where if I take the fraudulent ones, the number is 118. Although this doesn't tell us much, because the number of fraudulent job postings is also very less because the data is imbalanced. So we couldn't figure anything that is very uh, that we can make some inference out of it, but this is how it is right now. So we have also plotted functions and seen what is happening here. So this is the visualization for it. So highest number of functions are from IT and sales, as we saw earlier, and we are going for the missing data as well, because we have already handled the missing data for salary range. So salary range is not here, but the others are here, as we have not seen it, I have not handled it. So now we are going to create a matrix out of it and see for all this what is the visualization of the null values. So as we can see, location have very less values which are null. Department has quite some. Salary range we just handled. Company profile, we can see that company profile has null values. Description has no null values, and requirement, benefits, employment type, required experience, required education, industry, function, all of these have null values. So department, we are still in the univariate analysis. So next up we will start with the bivariate analysis. And we know we have categorical variables in telecommuting, has company logo and has questions. So what we'll do, we'll in a single plot, in a single using subplots, we have plotted the bivariate analysis where we are using hue as fraudulent. So for telecommuting, what we see that this is the distribution, and we can see where this is non-telecommuting, the fraud chances of fraud is high. So where the company has logo, we can see if the company has logo, the chances of being fraud job posting from that company is less than if the company does not have logo. And for has questions, we can see it is the same like has company logo, that if if it does have questions, then the chances of being fraudulent is pretty less than if it doesn't have questions. So we have already started with bivariate analysis. Then let's see for employment type. So this is one plot for employment type, but let's handle our null values first and then go for the plot. And we can see now that we have replaced the null values with not known here, and we can see that the not known has quite some posts that are fraudulent, and they have non-fraudulent as well. So what inference can we make from here? Let's see. So full-time job has the most non-fraudulent ones, and it has the most fraudulent ones as well. And as we can see, for a lot of job descriptions, there is no mention of the employment type. And for those where we have not mentioned, where there is no mention of employment type, we can see that there is a pretty high chance of being fraudulent. So let's go to required experience, and in required experience as well, we see that when it is not known, I mean there is when it is blank, then we are getting that there could be a quite high chance that it could be fraudulent. As we can see here, we have replaced the null values with not known, and here the most non-fraudulent post has come from that as well, and the most fraudulent post also has come from not known as well. So for required education also, if we post it, not known has the highest fraudulent and non-fraudulent ones. So these are the inferences that we could see so far. And let's see for this for the four categorical variables that we have, the three categorical variables rather, telecommuting, has company logo and has questions, how they are correlated with fraudulent. So if we if we plot a heat map, this is what we see, and this is very evident that we can see has company logo is negatively correlated to fraudulent, and the others we can see that has questions and has company logo, they are also very correlated as well. They have a positive correlation with them. Fraudulent has positive correlation with has questions as well, but they are not that significant. The most significant that we can see in terms of our target variable has company logo has is negatively correlated with it. So next comes the feature importance. So we saw that how the distribution is for those categorical variables with the target variable. But let's say we want to do some statistical analysis and statistical inferences. So how can we do it? So the best way is hypothesis testing. So we'll mostly tackle the categorical variables. So what we'll do, we will use a chi-square test to do it. So here we have taken the required packages, and as we can see for the first one we have taken has company logo and fraudulent. So what is our null hypothesis? Our null hypothesis is that they are not related, but what we are getting in the p-value is it is very less than our alpha, and as we know is as it is very less than our alpha, we can reject our null hypothesis and we can say that fraudulent variable is dependent on has company logo. And same we have done this on hash questions, which comes as the same result that it is also dependent on that fraudulent is also dependent on hash questions. We have performed it on required experience as well, where we have plotted these kind of tables, that contingency tables that we can in terms of when we use chi-square test, and this is what we are getting. Here also the p-value is very less than 5%, so we can infer from here that the required education kind of affects fraudulent. Same goes for required education, as you can see here, and the same for employment type as well. And lastly we complete with telecommuting, and this is also the same. Then comes, let's tackle the feature extraction. So what are you going to do? So let's say for location we have seen so far that it is comma separated values, but we can't go on and see take all three, right? So what we can do here is we can extract the country name, and we can see that which country has the highest posts and how they change with the fraudulent posts and as well. So what we have done is first we have tackled the null values from here, so which is not known. Null values we can see we can see that we have replaced this with not known, and this one we already have seen that London has the highest ports and all. So what we have done is have splitted it, and we have taken the first value, which is the country one. So now we can see that our new location column has US, Great Britain, Great Germany maybe. So these have the highest number of posts. Now we have initialize a dictionary because we want to see this in a visualized way. So, and we want to see which are the top 10 countries where we are getting the job postings, highest number of job postings from. So doing this we have seen that US, Great Britain, Germany, and these countries are the top three, and these are two in a total, these are the top 10 countries. And also we can see here for the lot of job postings they have not mentioned the place of the location of the job. That's why we are getting that not known is also there in the top 10 job posting locations. So now we can see missing data because again missing data because we know that we have handled quite a few missing data before. Next comes the main important part, because this is obviously we can see this is a NLP project. So for the NLP project we need to tackle the text data, we need to reprocess the text data, and we need to vectorize it. So that is the whole process. So first we will start with the text columns. So first of all, I'd like to mention why I have used location here. So location and its frequency, let's say like US has the highest job posting. So when we are using US, the frequency that the frequency that US has come in this data set can be very useful. And in the later part of the project, we have used TF-IDF vectorizer that can actually uh, use this feature and can turn it into a very useful feature. So here the text columns that I have used that I am going to concatenate later is title, department, company profile, description, requirement, benefits, industry, and function. So all of this I am going to first tackle the null values. So I have used the code here for I in text columns df.I fillna, and I have replaced them with empty strings. Here one disclaimer: if you can use a space, a full space here also, but it's up to you what you want to do. So now we can see the missing data. We don't have any more missing data. We have tackled the missing data so far, and now we'll pre-process it. And if we plot the matrix, we can see now there is not a single null value here. Next, we are going to take a look at how the text files, how the text columns look like. First, with the title, we can see marketing intern, customer service, and all. We can also see that there are some punctuations that are there, and later on we are going to tackle them. For company profile also, we can see the company name is Food 52, but we can't keep it like this. We need to pre-process these things. Here also punctuations are there for description and all, and DF requirements and all. So, and benefits and functions and department, we can see there are very many null values, and there are some punctuations as well. And if we see a little closely, we'll see that there are many URLs as well that are given. So for these URLs also, we have found a way to keep it and tackle it in a way so that we can keep some information that actually could help us when we make the model. So here comes the industry and all. So I have next what I have done is I have initialized a new column which is right now an empty string, which is the combined text, and now I have concatenated this combined text with all the text files that I have. Remember, I have already tackled the null values, so we should not have any problems concatenating them. So that is what we have seen. Now if we go to the first value, this is how it looks like. But as we have seen that there are many, there are small letters, there are capital letters, there are punctuations, there are, let's say, HTML tags. So a lot of things could be there. So here what we will do is first we'll tackle these punctuations and all and clean the data. But before that, one thing we need to see that when we are choosing our, because these words are going to be our features in the later part. So for the feature part, we should not address the words that are very frequently used in English, like let's say there is a, about. So there is a library or there is a package called stopwords and English stopwords that we want to exclude from our text data. So how to do that? So first of all, we need to import the package NLTK. Then we have to download the stopwords, and we need to make the set out of the stopwords, and I am removing the word not from it. But why I am removing the word not from it? So when we do a text analysis, not is a word that can actually preserve the meaning of the word, meaning of the whole sentence. Because I am a good boy and I am not a good boy, I am not a good boy is completely a different sentence. So that's why I have no, I have removed not from it, because I want to consider it when I am actually using it in the text process. So next comes cleaning the data. So here what I have done, I have defined a function. So the function will, what the function will do, it will lowercase the text first, then it will substitute the punctuations with empty strings, then it will substitute the HTML tags with empty strings, and underscores, then comes underscore, then comes the multiple spaces, then comes the digits, and lastly the single characters, and it will return the text as well. What happens next? So next I'll do what I'll do is I'll do a correct URL. I want to tackle the URLs. So what I'm going to do is I'll search the pattern for the correct URL, and if it is matching with the corrected URL, then I'll replace that URL with correct URL word, and if it is not, then I'll use the fraud URL word. So that's how we can keep the URL and see how frequently they are coming in. So combine text, what we are doing here, so we are applying the clean text function, and we are applying the correct URL function to the combined text, and this is how it looks like. You can see there are no punctuations, there are no texts and all, and we can see it is looking quite clean. But after all this, what is the next step? So let's say we have many words that actually maps to a single word. Let's say marketing comes from market, tasty can come from taste, tasteful can come from taste. So if we keep it like this only, this can create a lot of features that could be handled with a single feature only, maybe. So that's why we can use stemming, or we can use lemmatization. But I am going to use lemmatization here because I believe that with lemmatization I can actually preserve the sentiment analysis and the semantic meaning of the words better. So here what I have done is I have created a function that uses lemmatization, and I am going to use the lemmatization on the words, and I have applied it here, and this is how it looks like now. So so the text processing is almost done. So let's proceed towards, now that we have it, we can actually see how the text data is different in real job postings and fake job postings. So first of all, let's take two variables: real job postings, where we are using non-fraudulent text, non-fraudulent, and taking the text values from it, and for the second one, fake job postings, where I am giving the fraudulent ones and taking the values out of it. But before doing that, let's see how the string lengths are for these two. So I have taken the string length for fake in this one, real for this one, and for fake in the second one, and I want to see if they belong to the same distribution or not. So for null, what I have seen is, for my null hypothesis, I have taken that both the string lengths come from the same distribution, and my alternative hypothesis is that they do not belong to the same distribution, and my alpha is 5%. So if I use a case test here, because case test gives us an idea if the two distributions are coming from the same or not. So what we are getting the p-value here is, it is very less than 5%. So we can actually affirm from here that they do not belong to the same distribution, and they don't have the same median number of words also. So if we see the string length for the real job postings, we can see the median somehow we can say that it comes near 2000, but where for the fake job postings, the length, the median is nearly 1000 or even less than that. So this is quite evident from here. So next what we will do is we will try to fetch the words that are frequently occurred in here, in this word, in the real job postings and fake job postings. So here I have defined a function for word cloud, and this is how it looks like. And so here I have used this generate function, and this generate function is here used as well. So if we see that work, working, video, food, project, team, second, these words are coming for mostly for when we are using the real job postings. And let's say if we want to see the top 10 words when we are using the single words, and there is a concept I have used here for n-grams. N-grams means when n-grams is equal to 1 means I am considering one word, n-grams is equal to 2 means I am considering pairwise words. So here for the, sorry, for the one word, what I am using, what I am seeing is work, experience, service, team, customer, company, business, client, product, you. These are the most frequently used words here. And for the n-grams equal to 2, what I am seeing is this is how it looks like. So for the fake job postings, what I'm seeing is this is how it looks like, and the most frequently used words are like this: work, service, experience, team, like this. And for default dict, I am using a function here called default dict that is helping me to plot this. And I can see that oil, gas, communication skill, year experience, customer service, engineering use. These are the when I am using in graph is equal to 2. These are the frequently used words here. So next what I have done, because we need to vectorize all of this. So first let's go for the categorical variables. So I have used one hot encoding for categorical variables, and as you can see, the telecommuting has company logo, has questions, employment type, required experience, and required education. All of this I have converted them into vectorization form using the get dummies. Then I have going to the text data. I have used TF-ID vectorizer. I have explained how they work here. Here I have used 500 max features, because if you use 15,000, that could really create problems when we are actually doing the model. Because 15,000, we have only 17,880 rows, and if we have over than 15,000 features, that could create a problem. So as you can see here, it is vectorized, and we can see the data here: 5,000 features and 17,880 rows. Then we have made a data frame out of it, and we can see this is how the data frame looks, and we have 5,000 features. Next, we have concatenated the DF dummies and DF-ID of DF, that is equal to 1, and we can see the 28 features from there. I mean, the DF dummies have been concatenated. Next, we are going to what else is there. So we are going to drop all of the features that are not required anymore. So except for fraudulent, I don't think we need anything more here. So drop, I have used I have taken all the features from here and I have dropped it, except for fraudulent. So the only fraudulent is left in DF, you can see, and we need to concatenate that and make the final data frame, which is the final DF, and that is what I have done. That I have concatenated. And I guess, as you can expect, just a single extra feature should be on it, and that is what has happened. So I have defined y here, and I have defined x here. How is it? And then I have used the train test plate to actually train and split the data. So after this, if the features are very high, we can actually perform the PCA and we can build the model. But I have not done that so far. So that was the EDA that I have done. Hope you like the video. I have written a blog on it, and in the description of the video, it is mentioned. If you would like to go through it, then it will be there, and I will be also posting the GitHub link there. Thank you.